Okay, there's one here. Was there one at the back as well?
Hi, I'm Eric from ERICSSON. I wish this question will come from an operator, but I'm just curious also how different vendors react to this, or also operators. I mean, it's easy to tell the guys, the transport guys, from tomorrow you're going to do IP. For tomorrow you're going to do LDPs and you're going to do pseudo wires. But that will not happen very easily. So I think what some of the other operators show is not to shake the organizational box too much to keep also the employees happy. I mean, these also have a huge impact in your OpEx, if you put it this way. What are your views? Do you think it's easier to convince to extend the last mile to access or to bring the first mile to core? I mean, you have to do some stitching at a certain point if you don't want to shake your organization too much.
Anybody want to take that? I mean, you saw, Thomas already prefaced everything by saying that they did make a significant organizational change, which is what allowed them to move forward with a plan like that. But yeah, you're quite right. I mean, that's one of the questions that often will come up. You know, if you don't want to change the organization, let's hear what the panelists have to say about it, if they have an opinion.
It's coming back again to the right. Who are the people you're talking to? If it's a transmission department or it's a data department. And in some organizations, at least going some process of converging those two departments to one. And the question will be who will control this department, whether the IP data guys or transmission guys. So it's very much depends on what will happen in those larger organizations.
I mean, there are two different cultural mindsets that have existed for as long as IP has been around, and the transport mindset has existed much longer than that. And you know, it's going to take a very slow process for things to change unless, you know, somebody high up the corporate chain mandates it. You know, Cisco positions itself as a full service vendor and you know, we'll sell you whatever you want to buy. But there are certain architectures that we believe will win out in the end. And I think the economics for converging transport and packet will become compelling, and at some point in time, people will look at those organizations and say, these organizations are starting to do very similar things, and having separate organizations is also adding a lot of operational cost.
I would like to add that, like other panelists said, you know, after the department, even if the department can successfully merge, after the department merge, depending on whether the IP guy, you know, take the charge or the transport guy take the charge, MPLS may be, you know, preferred or not. But, you know, if you use Ethernet, pretty much everybody can accept that.
Yeah, that's true. In fact, I mean, I have a data point, right? I mean, if you look at TELUS, they have been proponents of Ethernet from 1995, and the CEO was seen talking recently, and he said that they found that from a cost per bit perspective, Ethernet has actually been outpacing every other technology there is. So they have stuck to Ethernet in the access and metro, and they have a standard IP MPLS core, and they're very happy with that. And they find that they're able to deploy all the services today, and they do a very wide variety of services. That's an example which is completely different from Deutsche Telekom, for example. So let's take a couple more questions from the audience, because we have about 6 or 7 minutes, or maybe 10 at the most to wrap up. So if there are more questions from the audience, I would love to get some more interaction. What about the operators in the audience? I mean, this question was posed to operators on the panel, but it could equally apply to the operators in the audience. Is there anybody who would want to respond to that or has a thought?
I think they've decided for the dynamic control plane in the poll of Maciek.
I'm sorry?
I think they've decided for the dynamic control plane, but with the poll of Maciek this afternoon.
All right, so then let me ask another question related to the, which has not yet come up, which is the OAM aspect. I mean, when we put MPLS to the access, you know, what are we going to do for OAM? You know, TP has one set of OAMs. If you're not really using TP, if you're doing seamless MPLS, then what are the OEM options? Could you comment on that? What are the opinions of the panelists?
I'll go. Oh, I think it's important to know the status of the network, and that's the reason for the OEM. You have to check is the connectivity there? Is the customer satisfied? Do you meet the performance management and so on? And therefore, I think the OEM has a goal. It's not there because it should be there. It has a goal. So OEM has to be assessed on the requirements. And for our understanding, the MPLS, it's very mature for some functionalities in the OEM. But I think there's also some room for improvement for OEM capabilities, also in the MPLS.
Absolutely. Yaakov?
Yeah. The OEM question, was, I guess, the main question that was going on in the IETF, ITU debate on TP. And there's a lot of stuff out there as it is. If you're bringing pseudo wires across, of course, we have the VCV. We already have several flavors there. We had under that all the IP stuff, the BFD we could do to begin with. Now we added another layer on top of that. OEM is supposed to be really, really reliable itself because you're checking the reliability of your network using it. And if we get the OEM so complex, and of course it's not just the fault stuff, we have to do the performance stuff, and we have to do the performance stuff in a way that you could see if something is starting to slowly go bad on you, and then we have to do the diagnostic stuff. So I think that's one of the real problems is we really going to come down to a minimal set that we can interoperate and check. Look at the Ethernet case, for instance. Why 1731 has lots and lots and lots of TLVs, different formats you can use. The MEF came back and said, we want to use one or two, not all the 24 or whatever it is opcodes that they have there.
So and
they went back to the ITU and said, we want to use it this way. They said, no, so they defined two more. So I think what we're going to have to do is out of all these new RFCs, figure out what the minimal set is, what people want to do, and make sure that that really works across all the platforms and gives us what we want, and then say, that's good enough.
That's great.
I would like to second that. In fact, with MPLS, I think it is a fact that the OEM has been too complex. One indicator of that is really, if you look at it, none of the, say, the silicon out of the box merchant silicon really did put MPLS OEM into the chip out of the box. That's happened only after MPLS TP standardized that.
Whereas
so
in Ethernet, that's not true. Ethernet, there are chips that
MPLS TP really borrowed that this one from Ethernet really, and took the same concepts in. And it's only with Ethernet and then now with MPLS TP that chip solutions for OEM are coming out.
I will make it more complicated because probably we have also optical guys in the room. So
yeah.
OEM is about layers. So what about photonic layer? You still have OEM on the photonic layer. And maybe if you have a photonic layer problem, you cannot detect it with Ethernet OEM or with MPLS OEM.
Sure.
Now, if you're going to the Ethernet, okay, so you detected the problem on the Ethernet layer, but you have forwarding information base of the router, so you need to detect it with a different mechanism. So it's a kind of holistic view of the things that need to be compounded from all the layers because it's starting from the physical layer going up. And this is unavoidable. I think if we try to segment it to only one specific mechanism, it's almost impossible.
No, absolutely.
Can I make it even more complicated for you? Based on the OEM, you're going to trigger some kind of protection mechanism. Now, if you have it running on the optical layer and you have a timer on that one, on top of that you have the Ethernet, on top of that you're running 2 layers of MPLS, on top of that you have IP. Each one of these has a timer and it's going to decide some kind of protection mechanism based on that, right?
Yeah,
but I think that you have to understanding of the clear architecture of the network. How is the implication between the layer and so on? And therefore, you have to know how do you operate the network, what are your real requirements, what is the impact between the layer 0 and the layer 1, and so on. And from my understanding, most of the problems are based because we are going packet. In the TDM scenario, everything was very clear. But I see also in the MPLS scenario, we have a lot of capabilities. We are very happy for that because ECM, or for example, ECMP, and that makes OEM complicated. If you have 100 ECMP passes through your network and you want to monitor every of the passes and you check, is there one pass broken or something else, and 1% of the packets of a pseudo-wire goes down because you use entropy flow level and so on. And it's a question, what is your requirement? Do you want to get all states from the network? How do you want to operate your network? And I think in some cases we also have to rethink about the solutions for that.
I think that you answer why some of the transport-oriented people prefers probably MPLS TP than the other one, but the good point is that at least we got rid of TMPLS, so at least we have one less.
No, but in defense of that, I think that there's one quick point I wanted to add, which is that you, in talking to some of the companies that I've talked to, I mean, when you have multiple layers, very often problems which are perceived to be at layer 3 ultimately end up being connectivity problems at layer 1. So definitely you need that. The other thing is that there are now vendors that are integrating packet and optics, and they are in fact using the visibility of layer 1 to see things at layer 2 and layer 3. We just at lunch with one such vendor that's doing a pretty good job of it. Their operator customer is pretty happy with that functionality. So there are vendors that are beginning to do that, and as we integrate packets and optics, that's likely to happen even more.
I think there was one story when we have started our first 2.5 gigabit links it was in Germany. There was also the mismatch between the optical people and the packet people, because the optical people measured the link, and for 1 minute everything was great, no bit error rate, but the packet people connected their routers via that, and the bit error rate or the packet loss rate was too bad of this wire, and they give it back, it's not good enough, and they checked it again. And that was a completely mismatch between the layers, because everybody lives in his own world.
Yeah.
But I hope in 15 years that has changed.
That could be at the same layer, by the way. There was a ad hoc group in MEF, because people don't really trust the service provider to Ethernet. In TDM world, people knew that you would get your 2.048. No one was going to get 2.046 instead, right? But Ethernet, you don't really trust what they're saying. So what do? You go out and buy a box. There are vendors who sell boxes that you can do performance management, right? And you test what you're getting, and the operator's testing at the other side of the link. Now, your time intervals are not exactly lined up, et cetera, and you all of a sudden discover that for 1 second he didn't live up to his SLA, right? And so you say, okay, I want money back. And he says, no, I see it's perfect, right? Now, when you start multiplying this at different layers and mixing them together, it becomes impossible.
So that's an argument for simplification of layers, right? I mean, you just make them as few as possible, Ethernet over optics. How about that?
If you make it easier, in other words, make it so like one combined layer with one OEM and one switching, yeah, that would be great. But I think some people will say that should be MPLS directly over optics, right?
That's another possibility.
Our customers want to have
IP MPLS over
optics.
Over DWDM.
Well, we have time for one very quick question from the audience before we wrap up the show. So let's take that, and then we'll bring this all to a close. Yes, sir.
Question, when it comes to, for example, multicast traffic perspective, and also from the convergence perspective, and unified performance management and performance monitoring perspective, I think this is something that we have not really discussed. So does it add any value to take MPLS all the way down to the edge?
Could you just repeat? So you said traffic monitoring, and
I said from the multicast traffic perspective, from the performance monitoring unified PM when we have just MPLS layer, and then from the convergence perspective as well.
Convergence of layers?
Faster convergence, like 50 milliseconds, or convergence requirements towards the edge.
So 3 things: fast convergence, unified management, and what was the performance management? Yeah.
I think there was also multicast.
Multicast, yes.
I think we know exactly how to provide multicast in an MPLS environment. Today we do it as IP multicast, because it's an IP router who does the multicast replication in the backbone. If we move MPLS down to the access node, or if we need Ethernet in the access node or something else, we have to identify what are the solutions. And the scenarios we have today in an Ethernet-based aggregation network, it's not very comfortable with IGMP snooping and so on, or we broadcast everything down to the customer. With the MPLS environment, I think we also have to consider what are the scalability issues and so on. And I think in many cases, IP multicast is IP-based, and IP multicast would be a very good solution also in the aggregation.
Okay. Any other final thoughts? So the 3 takeaways that I got is, 1, we need to work more on interoperability. We need to come up with a minimal set for OAM for it to be more useful. And we also need to consider very carefully our organizational structure as well as the interaction of the different segments of our network before we are able to decide which technology is the best. I mean, of course, we didn't expect to have a final answer. That was not the purpose here. The purpose was to expose some of the trade-offs so that when one is looking at either equipment design or network design, one can take these inputs into account and come up with something that's more suited to help the operators do a better job of what they're doing. So with that, I'd like to thank all the panelists and all of you as well. Some of them have come from very far just for the purpose of this panel, so I really appreciate it. And thank you, everyone, for your time this evening. We'll see you next year.